Right, okay, basics with variables. You need to initialize them. The equals is assignment. So as soon as you see an equals, you know that a value is getting updated. Okay, so if they ask in the exam, identify where a value changes, it's the assignment operator that you're looking for. If you've got something like this, where we've got a variable that's having a value assigned, and it appears on the right hand side as well, what's happening is that is being evaluated first. The assignment happens last. So we look up and we say, okay, what is the value currently of that variable? Retrieve that value, add the 6 to it, what is the answer? And then we update the value. Okay. The other thing with variables, the name, sensible name. If in the exam question they have given you a name of something, use it. Check the spelling and the casing of it as well. So if they say in the question, my val, and they're like capitalise the M and the V, make sure when you write it, you do it. Because remember about case sensitivity. Pseudocode, it doesn't matter so much. Okay, but in most languages, case sensitivity is an issue. Okay, or a feature that you can make use of. Right, just a quick recap, variables and constants. So a variable, it's a name that refers to a memory location. Or address. Memory address. If we're talking about CPUs, we're talking about memory addresses. Represents a single value of a single type of data. So that would be like an integer, character, string, boolean, okay, float. Right, and the key thing about it, don't just say its value changes, you've got to be more explicit about that. So the value changes during execution of the program. It's no good to say it just changes. You've got to say when. Okay? So a name, hopefully a meaningful name. And I'll give an example of that because I did one this morning with the Year 10 lot. I wrote this. And I'll tie something else with it as well. So f equals 3.1419 times banana. Okay? Standard formula for calculating the circumference of a circle. Okay? But not explicit and obvious unless you know that f is where we're going to store the circumference and banana is the diameter of the circle. Just by renaming this, so if I call instead of calling it f, I call it circumference. And I will improve this further when I talk about the next thing. And then I put diameter. Makes it more readable straight away. But one more thing that I can do to make it even more readable is to replace this literal value with a meaningful name. And that's what a constant is. So a constant is a name again. It's a name that refers to a value. So this is a big difference between what a variable is. A variable has a name that refers to a memory location where we store something. But a constant refers to a value. And it allows us to have meaning to a program. I'll change that example in a second and show you. It's fixed when we write the code. So once we've written that in code, that's it. Through the lifetime of the program, its value does not change. That's why it's called a constant. So it does not change during execution. Okay, so let's use a constant to make this more readable. I'm going to change this constant, the literal constant, 3.1419, and I'm going to use a meaningful name. And I'm going to use pi. So that gives me two benefits. This now becomes readable, but if I define what pi is, when I write my constant in code, there is nothing to stop me at a later date, if I have found some more decimal places for pi, to just update this value of this constant, and it will change this code for me. How I had it before, I'd have to update it there. And if I've used pi more than once in my program, which is highly likely, I'd have to update every instance of it. But with a constant, I get a single point of reference that I can easily update. So constants are useful because the names give meaning. Okay? Variables, with their names, they refer to a location. That is the major difference. Right, okay, some basic constructs, which everyone keeps forgetting what a construct is. Don't know why. We do. Right, constructs are building blocks. So we have sequence, which is just putting the steps in the right order, which is more common of a mistake than you'd think. And then we have selection, so that's making decisions. So whether we follow one branch through the program and execute certain instructions, or whether we execute other instructions. So in order to do selection, you can either do if, or you can do if else, okay, and so on, or you can do a select, which we normally call select case. So I'll give a few examples of those in a sec. I just want to do this basic thing. And then we've got iteration, looping. So we have got for loops. So that's our count controlled loops, which is what the example call them. So just be aware of that. We have got while loops, which are our 0 or many times they can execute. Because we test at the start, we can say, oh, don't do the loop at all. So 0 or many times. So the count control ones are fixed. We know how many times we want to do it. And then the final one is the repeat untils, where we test, we do the loop and then test at the bottom. So they always happen 1 or more times. And that's constructs. If you get asked about constructs or have to identify constructs in a program, you're looking for where we've got decisions being made and where we've got loop structures. Okay? Sequence is just an ordering thing. So it might be, for instance, if you want to do a calculation with some inputs, you might have 2 values input, and we want to do a calculation with it, a plus b. The sequence has to be, we get the input first, then we can do the calculation. It's no good doing that. That would be logically wrong. Okay? So it's difficult to identify sequence because everything's sequence. But selection and iteration, they'll expect you to be able to pick that up. So let's have just a couple of examples of some selection statements. I'm going to change the pen.
rubbish.
Right, so the basic structure is to say if. So we're asking a question. So you can have a simple comparison, which is what we always do when we're doing this. We're making a comparison and we're saying, is that statement true or false, that condition? Okay, if it's true, we have our true code, and that is the most basic. You can put an end if you want, you don't have to in pseudocode. So that's our basic one, where we're saying like, we either do this code or we don't. Whenever you get to the end of a construct, you carry on with the lines afterwards. So that's one form. You might have two choices to make. So you can say, if A is less than B, if that's true, do the true code, else, if that wasn't true, do the false code. Okay, so you've got like, I might need to do something or not, so you can just do a basic if, I'll put an end again. Or with two choices, you might say, right, well if this statement's true, do this bit, else do this bit. Whatever that code is. Notice I'm indenting. If you want to help yourself, you can do dots to show where things should line up. Right, you might have multiple questions that you need to ask. So there's like 4 different choices you have. So you might say, if A equals 1, then do so you might have a choice on a menu of 4 choices. You say, okay, then I could do if it's equal to 1, and we tend to put double equals, but it doesn't matter so much in pseudocode. But we tend to put double equals to say, is that the same as? And then we say, right, well, okay, we've handled the 1, what about the 2, 3 or 4? I still don't know. So I can say else if. How this appears in different languages doesn't matter. We're just showing the logical structure. So we say, okay, let's pick the other choice. So is it a 2 then? If it's true, do the true code for the 1, for the 2. But I've still got 3 and 4. So I've done that option and I've done that option. I've still got to cover 3 and 4. So I need to make another selection. So I can then say else if again. Let's test to see if it's 3. If that's true, I'll do the true code for 3. Now, I've only got one other alternative. So I can just put else. And then say, okay then, the false code is going to execute the stuff for 4. The only problem with that is if I stupidly enter 7 as a menu choice. If I enter 7, logically I'll say, oops, oh, it's not a 1, so move on to this decision. Oh, it's not a 2, I'll move on to this one. It's not a 3, and then I've got else. So I'm saying, actually, if they don't type 1, 2, or 3, I will do this. So you might need to say, okay, hang on a minute. Let's explicitly say, did they enter 4? And have that structure, and then for the else, at the end, say anything else, I don't know, print. And whenever you're using the print function, because it's a function, put the data you want to print in parentheses. So I'm going to say print unknown option or something, whatever it is. Okay, I'll just put an end at the bottom. So you can see the indenting's help there as well, because it makes it clear what's getting executed at each stage. Now, one thing that we do come across is you do have menu systems like this, and in most languages we have a system called case. Python doesn't have it, so you end up with this structure in Python. But the case statement, and I'll do it for this little example menu code, looks like this. So we have a select command that says, what are we looking at? So if you look at the ifs that I presented here, I've got A every time. I'm examining the value of A. So I'm going to say select A. And then what this provides is a short way of writing this big nested else if structure. So I say case, what am I comparing with? So I'm saying case, it's 1. And then what I can do is I can say, okay, that's the code code for 1. And then all I'll do is I'll list all the cases. So I can say case 2. So what this is providing is a shorter way of writing the same logic. Technically underneath, when this is taken by the language translator and turned into machine code, we're doing the same thing as we've got logically there. So I can put all my cases down. So a little bit shorter. If there's less typing to do, there's less chance of errors. Okay? And the other thing that this does is we have a default value. So we say anything else, and that's when we can do our unknown command or whatever we're saying. So it's identical logically, but it just allows us to be more compact, reduce the amount of syntax we have to present to the language translator. Okay, so that's our selection. So let's have a look at what our iteration looks like. Our 3 types. So the for loop. For loop has a distinct starting. We have the loop counter, or the control variable. We have a initial value, and we have a stop value, final value. There's one other thing that's optional, and that's to say step, which by default is always 1, so we increment by 1. But you can have negative values. You can go up in 2s, 3s, depending on the task you're doing. You've then got your structure inside, so you have print. Now obviously I'm just using print as an example. And then we have next. Now what happens when the loop happens the first time? P is set to that initial value. Okay, and then we enter the loop. So in this case we're printing out P, so we're going to print out a 1. Then we hit this next line, and what I would advise is if you see something like this, you draw an arrow to say where it goes back up to. So next just says, go and start the loop again, but increment the value of the counter variable. So by default, that is the default, step 1. So we'd add 1. We keep doing the loop by checking this value. Once we've gone beyond that value, so in this case, because we're going up in 1s, it'll be 11, then the loop ends and we carry on down here. Okay? So this will print out a sequence. If you are working with an array, and you want to print out each character or a value from an array, so let's say we've got an array, of numbers, and we're going to call it, I don't know, nums or something. Okay, so we're going to have an array called nums. So this would look, if we was to draw this, consecutive memory locations, zero indexed in array. Okay, so there are 10 items, so that's 0 to 9. So if we want to process this array, we need a loop value that starts at 0 and goes up to 9. So we could write down the fixed number 9. But there is a standard way in pseudocode of specifying the length of an array. So this is an array that we know has got 10 items in it. So we can say, what do I call it? Nums.length. And that will give me the value 10. but I want to go from 0 to 9. So I might say that. Okay, length minus 1. Because by writing out the indexes, I know what I want to stop at. So I'd always advise doing that. And that will allow me to then print that out. So remember, an array, a little bit like a variable, it's got a name that points to a memory location. And in this case, the name points to the first item in the array. But in order to reference all the different items, I need two pieces of information. So I need the name of the array, and then I put square brackets, and I say then what position in the array, what index. That's what we're using the counter variable for. So in this case, we can just say, oh, at position P. The first time through, it'll be a 0. Then it'll be a 1, 2, 3, all the way up to 9. So we'll get each character one at a time, or each value one at a time for this array. So processing array is quite simple. Let's have a look at another thing that you use a loop for, a for loop. Because you know the array's length, that's why you pick a for loop. So you might need to initialize an array. So to initialize array, you're going to have the same structure, and I'll use this nums one again. I'll say len minus 1, and then I say, right, okay, I want to set a value, so I put the name of the array, put the index value, which I'm using this variable p to control, and I'm going to initialize it to 0. So that's how you initialize a one-dimensional array. If you've got a 2D array, so let's do a little example of that. So let's say I've got a little grid. So I'll call this a 2D array grid. It's got indexes 0, 1, 2 for the columns, 0, 1, 2 for the rows. Okay? Now, I cannot use a single loop to initialize a 2D array because I have got to traverse each row column by column. So I want to go this one, 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 this one. Now, if you're really stuck as how to do this, what you should do is write down the two indexes. So if you go, right, the order I need to visit these is 0, 0, 0, 1, 0, 2, assuming the row numbers coming first. Then we're going to look at row 1, column 0, row 1, column 1, row 1, column 2. Then we're going to finish off with row 2, column 0, row 2, column 1, row 2, column 2. Now what you've got to identify is two sequences. There is a sequence of rows, so we do for a row, we then go, right, column 0, 1, 2. So for each row we do, so in order to generate that row sequence, we need a loop from 0 to 2. So let's do that bit first. Meaningful variable names will help when you do these sort of things. So I'm going to say for row equals 0 to 2. And then I'm going to say next. I'm going to end it with two loops here, so I'm going to actually say next row. So I'll make it clear. And I'm showing the indents. Right, so that will generate this outside sequence. But for each row, guys, keep the volume down. I am trying to help you. Right, we've got that outside loop. We now need another loop. So for every time rows 0, I need to go 0, 1, 2 for a column value. So all I've got to do is another nested for loop that starts at 0 and goes to 2. I've identified that by writing them out. So that's going to be next column. So I'm actually saying column so that I know that's the value that I am incrementing. So if I want to reset these all to, I don't know, I'm going to make them all 10. So I need to put the name of the 2D array, which is called grid, then square brackets, and then I need to put 2 indexes down. Because I've used sensible names, I'm going to write row, and then I'm going to say that's the first index, the second index is the column, and I separate it with a comma. And then I say what I'm going to set it to. So I do my assignment operator, and in this case I said I wanted to set them all to 10. Okay, so if you're messing about with 2D arrays, you'll always have a loop inside another loop. Okay, so for loops are great for working with arrays because you know how big they are. Right, the other 2 loops, while loops. Right, the basic structure of a while loop is the keyword while and then a condition. Okay, so we can do if this condition is true, so when we evaluate a is greater than 5, we do the contents of the loop. If that is no longer true, we do the statements that follow the loop. In order for this to work, we need an initial value of a. So we must, before we start the loop, set this guard condition up. So in this instance, I've said a equals 7. When we hit this line, this is evaluated. So we say 7 is greater than 5. Yes, that's true. So we go in and we do whatever actions we need to do inside the loop. In this case, I'm just printing out a. Now, if I left that like that, there is nothing inside that loop that is making a change to a. So that condition's never going to be anything other than true. That would give us an infinite loop. So we always need to make sure that something happens inside the loop that will make the condition eventually turn false. So in this case, what I'm going to do is I'm just going to say a equals a minus 2. So I'm reducing the value of a. So it starts bigger than 5, so eventually, hopefully, we'll get to a point where this is no longer true, and then we will carry on the lines. In order to prove that, we need to trace this code. You might need to do this in the exam. You might get given a bit of code, and they'll say, how many times does this execute, or what are the outputs? So let's have a look at how we trace it. So we need 2 things. Our finger to keep track of what line we're on, and a little table that keeps track of all the variables. We've only got 1 variable in this case, so we've just got a. So all we do is we go line by line. So we start here, we've got an assignment. So at that point, a becomes 7. We then go to this line, and then we need to check to see if this is true or false. So what we do is we look up the value of a. So look at the last number you wrote down for the a column. We can see it's 7, and we're actually doing this. We're saying, is 7 greater than 5? Well, when you write it like that, it's obviously true. So that is true. So let's go into the loop, and we print out a. So we're going to print out on the screen 7. We then get this line. Now this is an interesting line. We've got an assignment, but first we need to evaluate this right hand side. So in order to do that, we've got to look up the current value of a, which is 7. We can then subtract 2. So when we do 7 minus 2, that gives us 5. Once we've evaluated it, we can assign the value to a. So you can only do the assignment at the end. We then get back to loop, and that tells us to go back up and test the condition. So we look at this, and we go, okay, 5 is greater than 5. That's not true. 5 is not greater than 5. So what we then do is you say, okay, do not do the things in the loop and move down to this line. Okay, that is tracing. So you can see that the the condition was tested twice, but the loop executed once. If I'd have changed this to 4, and this is the essence of how while loops work, as soon as we hit this line, we say 4 greater than 5. No, that's not true. So if we set this up in a certain way, we can actually make this not execute at all. So a while loop is a 0 or many times loop structure. The final loop type is repeat. So let's just have a look at the structure of it. Starts with the keyword repeat. You then put your statements in. So I'm going to keep with this daft printing thing. So I'm going to say A equals 7. And then we finish the loop with a line saying until, and we put a condition. Okay, so the way this works, you will always do the loop the first time through. The condition, and it reads like English, so we say until A is less than 4. So we want this as soon as it's true, the repeat until loop stops. Okay? Because it's sort of like the negative way that the while loop's done. So again, just like the while loop, there has to be something inside that will eventually stop the loop. So if we, I don't know, let's just do a decrement. So we would start this loop. Let's just run this through. So we've got A equals 7. So let's keep track of what A is. And then we print A out. So let's print 7. Then we've got this line that says, look up the value of A, 7, take 1 away from it, gives us 6, and store it in A. We then get this, and we say, is 6 less than 4? That is not true. So we haven't reached our stop condition yet. So we say, okay, go back up and do the loop again. So we print A out, and then we do the decrement. So we look up A, which is 6, take 1 away, it becomes 5, and we store that. Then we're doing this test. Is 5 less than 4? No, it's not. So we go back up and do the loop again. So we look up value of A, which is 5. Then we do this. So the decrement bit. So we look up A, 5, take 1 away, it is now 4, store that in A. We get to this. Is 4 less than 4? No. Do not do the loop again. Carry on. Now what you've ended up doing is you've got a sequence of values for A, but we only printed 765. We did not print the 4. If we'd have gone round and done the loop again, we'd have printed the 4. But the condition we used on the until stopped that happening. Now, one thing that this is super useful for is things like passwords. If you've got an action where you know you need to do a set of steps at least once, that's what a repeat until is actually very useful for. So you can say until pass equals, I've got a dumb password called in. So I'm going to ask someone to input a password. And I'm going to check. So if I leave this as it is now, I'm going to say, right, input the password. If I type banana or dog biscuit as my password, when I get to here, we compare it and say, is dog biscuit the same as in? No, it's not. Go and do the loop again. Okay, so that is a system that will infinitely ask for the users to enter their password until they got it right. That is opening yourself up for a dictionary attack. Okay, you should never really have infinite attempts at passwords because you can just write a program to keep trying passwords. So what we can do, and what is really quite nice, these conditions, you can have compound tests. So we can use and or not. So we could write, let's call it tries. We could have a value called tries. So we give the user 3 attempts. Okay? So every time they have a guess, we could reduce the value of tries. So we can say tries equals tries minus 1. Okay, so we're counting down. When they've had their 3 tries, the value of tries will be 0. So what we can say, they either get the password, okay, so we want either statement to be true, so we use an or. So say, if one of these is true, don't do it anymore. So if they've had 3 tries come out, even if they haven't guessed the password correctly, okay, and then we do the lines afterwards, and you make whatever decision you wanted. So repeat untils are really useful for password attempts, or anything where you're making attempts. Okay? Right, the final thing that I want to just quickly go through is functions and procedures. Right, a procedure is a set of instructions or steps that does a particular task. They can have no parameters. And we show that there's no parameters by putting parentheses, opening, closing. All the parameter is a value for that block of code to work with. So you can have procedures that don't need any data, okay, and they just do their job. This might be, I don't know, input, so you don't need to ask the user anything, you say, oh, give me some data. But if you need parameters, you give them sensible names. And that is what we call a parameter list. So we've got 2 pieces of information. So the statements that are inside here are dependent on the task we want to do. So this might be a procedure with a daft name with 2 unmeaningful parameter names that just prints something on screen. To use it, we have to call. So this just defines the statements that do the ARM process. This will be calling the procedure. So we put the name of the procedure and we give it its parameters. Those parameters can be just values, or they can be variables. So a variable called num and a variable called dum. The values of those 2 are passed to the procedure. The only difference between a procedure and a function, I'm going to give it a really cool name, arm2, just because I want it to just look the same. The only difference is a function does a series of tasks, whatever those tasks are, but a function always returns a value using the keyword return. The use is the same, so I can put arm2, which says run the function, and pass it some values. But in this case, this function takes 2 numbers, adds them together, and then returns the answer. If we just call the function, we're throwing away the answer. So we could do with storing it. So if we say A equals arm to 10, 10, we're going to get a result which we then store. Now you've already done lots of functions. Whenever you do input, that is a function. So whenever you do input, you must say store the data somewhere. Input is a function that gets whatever the user types at the keyboard. we need to store that so we can use it later on. Okay, so with functions, the names you give are important. Meaningful names. Meaningful names for the parameters. If you're given a function in a question, you use it like that. Okay, that's as much as I'm going to do. Good luck on Thursday.